Hey guys, welcome to Cafe.io. In this video, we will be talking about SQL and NoSQL databases. Let's get started. Databases are really interesting. When it comes to comparing them, essentially, we have two primary databases, SQL versus non-SQL. SQL databases are traditional relational databases. These are in the form of rows and columns. We access the data using a structured query language. They are ACID compliant, which really translates to having a good degree of guarantee about data and transaction control. The full form of ACID is atomicity, consistency, isolation, and durability. Go back and refer to some of your database principles, but this is really one of the key factors that differentiate relational and non-relational databases. They have a fixed schema and they scale up, and scaling up is really more like a vertical scaling. When you look at NoSQL databases, they are very different. NoSQL databases, as it says, are completely non-relational. There is no declared language in terms of the structure of the data. Usually it's JSON most of the times. There is eventual consistency, and it's very different from traditional rows versus columns and ACID. The schema is really dynamic. It can be ever changing, and they scale out. Now, when it comes to comparing these databases, a lot of times people want to start with simple NoSQL database because they're easy, a little bit fun, easy to play with, goes really well with the JSON style and do when especially when you're building APIs. However, this conversation is much more deeper than that. You need to be really aware about the nuances and the differences around which database to select and why should you select it. For instance, it might look easy when you're working with data which is JSON. However, if you want to guarantee transaction control and your systems require some sort of a specific pattern where it's guaranteed that the transaction occur, things like banking systems and mission critical systems, you might not be able to use NoSQL databases, at least in the way you imagine it. So in this video, what I'm going to do is go a little deeper and look at top 7 considerations which have been published by MongoDB. And you should consider these when you are evaluating NoSQL databases. Let's get started. So they have tried to talk about different aspects like consistency and transaction guarantees, visualization, and other capabilities. And then some not so critical elements, but we'll still get into that. All right. So here's the PDF. You can go to the MongoDB website and download it, but let me just walk through that. All right. So the first consideration that we'll go through the entire 18 pages. This could be a little long. Please bear with me. If you're new to my channel, I talk a lot about AI, software architecture, MLOps, and essentially these kind of conversations. Please do subscribe. The first is really data model. Second is the query model. Third is consistency and transaction model. Fourth is interfaces, mobile data, data platform, community support, and really the freedom from lock-in and all that. So let's go and deep dive into each of them. So the first parameter, which is the data model, essentially is the key differentiating factor, which NoSQL databases differ from relational databases. So it's essentially the data model. And you could think of it, no key value is most primitive form of non-tabular based databases. So you have tabular and then you have key value, and that's how this is represented. Can obviously specialize into some or multiple different kinds like graphs and stuff like that. The typical examples would be Amazon DynamoDB, Redis, HBase, Cassandra, etc. There's multiple different kind of key value databases and data models available. But essentially, if your core data is tabular, it's nicely represented in rows and columns. Do not go to NoSQL databases, at least not for your transaction stuff. The next parameter is really the query model. Each application inherently has a different kind of querying need. Sometimes you might just need to access basis a primary key, and in most of those conditions, NoSQL databases would be good. However, you might be storing data across multiple spaces, schemas, and you might be required to join them. And doing those sort of operations in SQL versus NoSQL, there's a significantly large difference in terms of performance and time. So this is another parameter to keep in check when you're building databases. Third is the consistency and transaction model. As I was saying, most NoSQL databases offer atomicity guarantee at the level of each record, and atomicity is one of the the first one essentially, right? Sorry, atomicity. And then you have the consistency, you have isolation and durability. And depending on the type of database you select, it might offer isolation, might offer durability, but it's very unlikely that you will not be able to find that in a NoSQL database, which is completely guaranteeing ACID. There are some databases which offer ACID-like properties, but to the best of my knowledge, it doesn't exist. But please do comment if you're aware of certain products. MongoDB really has multiple options around it. It supports multi-document ACID transactions, etc. It's there's still slight differences in the nuances. While they do say ACID, but there's still slight differences in the nuances. Then comes the consistency and eventual consistency conversations. Uh, Essentially translating to that, if you have multiple servers, data is eventually consistent, which means the synchronization is eventually happening. There might be a period of time when the data between two servers is not same. So let's say you're sitting in India and you have a server closer to India, and then the second server is in US. Depending on where you are served, there might be a period that if your call one goes to data center A and call two goes to data center B, you might get different answers. So typically that's something that we should keep in mind, and essentially key value databases are mostly offering eventual consistency. So different consistency modes essentially will provide different trade-off for applications depending on your availability requirement, performance requirements. There is no one size fits all. Please do your assessment and please evaluate both options judiciously. Moving forward, interfaces. Again, to me, this is not a decision point between SQL and NoSQL because most SQL databases will provide different tons of great interfaces, different sorts of drivers, and so would NoSQL databases as well. The only differentiation when we look at interfaces is SQL. And again, most NoSQL databases will also have SQL-like languages. So if you're familiar with SQL, it's a very, very easy compatibility. However, when there is a specific case where I think this becomes really critical is when you are translating or moving data, right? In those scenarios, you have to really pay very strong attention to the type of interfaces supported. CLI, visualization and reporting, all of that is good. Mobile data is more of, how can you get data closer to the users because so that the interface and exchange is faster. And typically for mobile devices, there's some databases like SQLite and all which are popular within the Android ecosystem. Not familiar with what iOS uses, but you do have some options on both the sides to be able to put a database on the app. However, these are not databases that are eventually used for storing large data. So this is also, this should be an important requirement, and in most cases you might want to have both, specifically for a mobile. Data platform is more of how the whole data management, the privacy requirement, the regulatory stuff, the centralization of data, the security considerations, all of that is factored in. Traditionally speaking, most, if not all, relational databases, they would really support all kinds of security considerations, be it from an infrastructure perspective, be it from running an enterprise application perspective, be it with regulatory and compliance of governments and stuff like that. I don't consider one or the other better in this case purely from a data perspective, but again, this is MongoDB's view, and I do think that most databases are now available readily on cloud. and different cloud providers are offering it really, really quickly. You have SQL databases from Azure, AWS, and all cloud providers will have Postgres. They'll have some version of MongoDB. So really, to me, this is more of a preference that you end up with, or driven largely by other kind of requirements. Last, commercial support, community strength, vendor lock-in. I think this is true for almost every product and everything that you evaluate, not really just databases. So you should have very strong commercial support if you're choosing a paid software. There should be community backing it up, because a lot of times what happens is the answers are given faster in communities, speaking from a dev and day-to-day interaction perspective, and then you should get some degree of vendor lock-in freedom. However, that is really, really unlikely the case with databases. My personal opinion on database technology is that it's probably the last piece of software that's gonna get ever migrated. uh, if it ever gets migrated, I've seen people do a lot of migrations of application stuff and all of that, but they choose to stick with databases purely because of the fact that nobody wants to touch it. And so typically with databases, you do end up with vendor lock-ins, and I think that's usually okay, because specifically with modern database providers like MongoDB, SQL, Postgres, these are all really mature products and crazy, crazy optimal at what they do. So support and all isn't usually a problem. All right. So that's us discussing few points around why and when should you select NoSQL versus NoSQL. This was more of a conversation. If you have liked and want to see more of these kind of conversations, please do put that in comment. If you want some specific comparison in the tech space or want me to make videos on a topic, drop that in the comment box. Again, this is Akash signing off. Bye bye.